Hello, I'm Roman, and welcome to the series of the videos Learning Golang. For those of you who already been on this channel, you know that I'm writing the kind of live coding videos of me learning and implementing some stuff. For those of you who are new here, again, hello, I'm Roman, and on this channel, I'm recording the videos to showcase that you can learn and implement anything with the time and the dedication. And you might saw that I finished the previous series, which was called Neural Networks from Scratch in Golang, and it took me around 73 videos to actually go through the whole book and implement all of the things. And I've been thinking that while I've been trying to use Golang, and I've checked some of the things before, but I didn't actually, fully dive into the language specification, etc., etc. So I kind of learned on the go. I don't go while, on the go. And what I decided to do, I decided that before I will do some next series, and I've been thinking about going deeper with the convolutional neural networks with the Golang, co-implement the simple rendering engine, and I actually have lots of the ideas what I want to implement, and I most likely will do it with a Go. So I've been thinking that it's a good time to actually practice and learn Go first and then move forward. And I know that there are people in the comments and then on the Discord channel that I have, they shared with me that they like to watch this series because I've been posting them consistently. I had to skip several videos for personal reasons where when I really wasn't able to record, but in general I was recording 6 times per week, posting them regularly, and people told me that they found it motivating. Like they found the motivation in this, and kind of I hold some people accountable to learn new stuff. So if me recording this series showing you that you can actually learn anything, and it's okay not to know everything, and get back to the newbie state and learn something from the ground, helps you to learn new things, that's good. I think, well, in that case, for me, the purpose of this series is fulfilled, and I will push myself to continue following my commitments of posting regularly this type of the videos. With this series, I'm not sure I will do it 6 times per week. Probably I will do it 5 times per week because I still didn't record any videos on the main channel for more than a month for various reasons. But right now I should have more time to do this. But what we're going, and this series of the videos shouldn't be very long, to be honest. Maybe, I don't know, maybe 2-3 weeks top. So what I'm going to do, there is a Go dev website that is about the Golang. If you used Go at least one time, you probably know this website. And there is a documentation, there is Go by example, which probably I will take a look later. There are some tutorials, but there is one thing that is called Tour of Go. Interactive introduction to Go in 4 sections. Each section concludes with a few exercises you can practice what you have learned. And what I'm actually going to do with this video, I will record myself how I'm passing through this tour. I will give some comments and based on my experience and my expectations from the language, because most likely for me, some things will be very simple, some things might confuse me. That could be the opposite for you. I came from the languages, like I used to work with .NET and specifically with the C#, then I switched to the mobile and I used languages like Swift, Objective-C, C++, and a little bit of the scripting languages like Python, Ruby for the infrastructure, and I did a little bit of the front-end development, so I know a few things from the JavaScript and the TypeScript. So I have some experience working with the different programming languages, and it could influence how I will understand the material here. I know that the most confusing things from the Go is the channels. So I'm actually expecting and very interested how, because I didn't have the chance. Well, I mean, I could have used them, but I didn't have to in the neural networks from the Scratch series. So maybe after going through this tour, I will revisit some of the code and actually integrate if it will make sense. So what we're going to do, we are going to start it today. I'm still a little bit sick, so sorry if I will do this from time to time. And let's say probably the first video will be shorter, like maybe 30 minutes, just for me to get into the speed of the recording once again, because I took a small break between the new renders from Scratch series and this one, but I wanted to be it 1 week. Okay, I wanted to skip 1 week and took a break from recording of the live coding series, but turns out I'm kind of get used to the recording of such videos, and it's, it feels uncomfortable for me not to do this. Okay, let's go. I think that should be fine that I'm here. Most of the codes, but I cannot move it. Okay, let's see. Maybe I will move myself in another place, but let's see. So, welcome to the tour. The tour is divided into list of modules that can access by clicking the tour of the Go on the top left page here. Okay, so there are basics, methods in the interfaces, generics, and the concurrency. So I would assume that I will go through the basics and the methods in the interface much faster because I already have some experience. But with the generics and the concurrency, I think that will be the most interesting one. Previous, page up, page down, the door is interactive, you can run. Okay, if the remote server program. Okay, hello. When you click on format, Control Enter, the text in the editor is formatted, right? Nice. It would be cool if they would support basic Vim motions, because right now because what I want to do right now is this, but okay. It is available in other languages, but well, I will stick to the English because most of the people will be using, and there is a version of the offline tour, but I don't need this. This tour is built on top of the Go Playground, a website that runs on the Golang servers. The servers receives the Go program, compiles, links, and run the program inside the sandbox and returns output. There are limitations to the program. In the playground, the time begins at this one. Determine the significance of this date is an exercise for the reader. Okay, probably it's the date of the release of the Golang. This makes it easier, or invention like first commits, or I think that's the release date. There are also limits on the execution time on CPU and memory usage, and the program can access external network. Playground uses the latest stable version of Go. Read inside the Go Playground. I don't need. We finished the first model. Now click on the go to the next section. Okay, so packages. Every Go program is made of the packages. The program starts running in package main. This program is using packages with import paths fmt and math/rand. By convention, the package name is the same as the last element on the import path. For instance, the math/rand package comprise files that begins with the statement package rand. So yeah, I think that should be this one. So we can use rand and no. Oh, it will be hard to type this. So basically it will be run, but I think there is a way to make an alias. I don't know, maybe this. right? Import undefined rent, so I think that will be like this, right? Yes. The code groups the import into parentheses factor it import statement. You can also write multiple import statements like import this, but it's a good style to use the factorize import statements like this. I mean, the most confusing thing for me is that I have to use quotes for this one. I never experienced it in any other programming language. So, but yeah. In the Go, the name is exported if it begins with a capital letter. For example, pizza is an exported name, as is P, which is exported from the math. Pizza and pi do not start with the capital letter. Yeah, when importing a package, you could refer only to exported names. I think this is, very... I found that's actually interesting convention, because instead of using, private and public modifiers, you just do it by name. And I think the interesting thing that there is no too many complex modifiers. For example, if you take a look at the Swift, like at the current version of the Swift current state, there are modifiers like for the function I'm remembering, it's like public, open, private, internal, file private, too many of them. I mean, yeah, each of the modifiers serves its own purpose, but just too many of them. But I think this is a very good. You don't have to, like, for example, if I wrote this exported, this is the exported func, right? But this one func not exported, right? Pretty convenient, pretty easy to follow. Function takes 0 and or more arguments. In this example, it takes 2 parameters of type int, this one. Note that the type comes after the variable name. Yeah. About why types look the way they do, see the articles on Go declaration syntax. Smells like C. Yeah, maybe I will read it afterwards. Functions continued. When 2 or more consecutive name parameters share type, you can omit, so for example, x, y, int. And swap function return 2 strings. So it's basically like in any, for example, in the Swift and other languages, it's just return it. It's called a tuple or cortege, I think. Well, tuple is a two things, but the cortege, you can return many things. And I think that's the same here. You can return multiple things like this. And for example, that should work. Okay. Named return values. Okay. Go's return values may be, so they are treated as variables defined at the top of the function. These names should be used to document the meaning of the return values. A return statement without arguments returns a return statement. Without arguments returns a named return values is known as a naked return. Okay, so because I have the x and y here as int, and I have them here, I can just write return and it will match that it has to return x, like this x. That's interesting. I would not actually use it really. For me, it's just... I think it's too many things you have to keep in mind, because for me, it just would make more sense, like... not make more sense, but for me, it's just easier to read. And that's it. Naked return statements should be used only in a short function, as the example shown here. They can harm readability in the longer function. Okay. Yeah, I would just not use it, to be honest. But that's good to understand how it works. The var statement declares a list of the variables as in function argument list. the type is last. So we can var I int, and then we can, okay. Var statement can be at package level, see both in the example. And I'm interested in what will be the values here. Okay, so it takes the initialized with the defaults, kind of false, right? Well, declaration can include initializers, one per variable. If initializer is present, the type can be omitted. The variable will take the type of the initializer. Basically, here it will understand that C is bool, Python is false, or Python is bool, Java is string, and same for this one. But what if I will do something like this? Will it work? Okay. How it's I think it's reflect, and then fmt print len reflect type of, if I remember correct, no, type of nj, and should be float. Float, right? Short variable declaration. That reminds me of my time working with Delphi. Inside the function is the short assignment and can be used in place of a var declaration with implicit types. Basically, this is the same as var k int equal to 3. Outside the function, every statement begins with a keyword, so this is not available. Okay, so I cannot write, no, for example, so that should not work. Non-declaration statement outside. Okay. Go basic types. Bool, string, various numbers of the integers. What is this? But there is an integer type that is large enough to hold a bit pattern of any pointer. Okay. So we have the integers and we have the unsigned integers of various types. Byte, which is the alias for unsigned integer 8. Room represents a Unicode point. Oh, okay. Float 32 for float 64. Complex. This example shows variables of several types. When you need an integer value, you should use int, unless you specify the reason to use a sized or unsigned integer type. For example, by default, I can use int, and based on the operating system we're working on, it will use this one or this one. Usually, using an unsigned integer, you need to understand why you need to. For example, byte or unsigned 8 is usually a first choice when you work with the, for example, RGB channels in the image. So what we have here, so there is I think there is something to work with the complex values. So there is a bool, there is a max int, as an unsigned, yeah, and it kind of uses the overflow, right? Oh no. no. Forget. I told it incorrectly. So I think, yeah. In variable as in 64. Too much. Zero. Variables declared without an explicit initial value are given their zero value. The zero value is 0 for numeric types, false for the boolean, empty string for the strings. But what, for example, will be for the reference? Probably nil, right? Yeah. Well, not for reference, for the for the reference. The expression t from v converts the value v to the type t. Okay, so if I want to, so there is, unlike in C, in Go, assignment between items of different types requires an explicit conversion. Try removing, yeah, and see what happens. So basically it will be compilation error. For example, in C, you can declare like, for example, an integer value and then declare a float value and then directly take the value from the integer one and it will be fine. But with, I think, most of the actual programming languages, they kind of requires you to do the explicit conversion. And I think that's better. Even if it does nothing under the hood, I think for the readability, this is just a must-have. So you'll actually see, because it might be hard to remember all of the, for example, that could be taken from some function result and then you assign it to this, and yeah, you kind of you can lose the track of the types. Type inference. When declaring a variable without specifying an explicit type, the variable's type is inferred from the value on the right hand side. When the right hand side is of the declaration is type, the new variable is of the same type. Okay, that just understands from the const value that we provided. Try changing the initial value of v in the example code and observe how its type is affected. Constants are declared like variables, but with const, like in many other languages. Can be characters, strings, boolean, or numeric values. Constants can be declared using this shorthand syntax, because it's basically a shorthand for variable creation. Right, so we have the const b, and we can change it. Numeric constants have high precision values. An untyped constant takes the type needed by its context. Try printing needing big 2, and int can be stored at maximum 64-bit integer and sometimes less. Create a huge number by shifting 1 bit left 100 places. In other words, the binary number that is 1 following by 100 zeros. Shift it to right against 99 places, so we'll end up with, okay, auto. Needs int big. Can't use big untype int constant as in value in the argument. Yeah, just overflows. So the value is so much big that it cannot fit into the type. Finish the lesson. Go to the next one. War. Actually, can I take a look? Oops. Oh, maybe here. Basic import 0. Okay, this one. This is actually cool that if you take a look, that's like, this is the whole tour of the Go, and I think it covers like the language itself, and even there are some exercises. So I think this is why Go kind of became popular, or it has wide and wider usage. Don't want to say it's a simple language, but it's a straightforward language in some cases. I heard that a lot of the troubles causing developers is like concurrency, the Go's concurrency, and some limitations of the languages that requires you to do certain things like very verbose. But I mean, I think that's we'll see. We have the 4. Okay, focus only one looping construct. Nice. The basic for loop has 3 components separated by the semicolon. Executes the init statement, the condition, and the post statement. I mean, like in the C. And you can omit some of them. So you can do this, right? So that should work the same. Undefined I var I. Yeah. The init statement will often be a short variable declaration, as the variables declared there are visible only in the scope. Yeah, so if I declare it a variable here, it will be visible only in the scope of the for. So if I'll go, for example, in the previous version, go outside of the for loop, it won't be visible. The loop will stop iterating once the Boolean condition evaluates to false. Note, unlike other languages like C, Java, JavaScript, there are no parentheses surrounding the three components of the for, and the brackets are always required. Yeah, because for example, like C version could be, you know, like this. I think it's I less than, I don't know, 10 plus plus I, and then you can do, you know, like some without parentheses if it's only one line. Okay, I don't remember about the C, but C++ should be doable in some other languages. The init and post statement are optional, so the condition is only a requirement. At that point, you can drop the semicolons, sees while is spelled or. Okay, so basically there is no semicolons, it's just while. Just if I will do this, I think it will be okay. So this is basically while true. Okay. No? Yeah. Okay. If I made the loop condition in the loop forever, so an infinite loop is compactly expressed. Okay, so basically while true. Goals if statement are like its for loops. The expression needed to be surrounded. The expression needs not be surrounded by, but the brackets are required. Okay. Like for, the if statement can start with a short statement execute before condition. Okay. Variables declared by the statement are only in. Oh. So for example, if I have a function that returns an error, func do, and it returns the error, right? And for example, I return errors new thing new like this. And can I do then if error equal to 2, error is not equal to nil, and then t print ln error. Can I do something like this? But if I will return nil and t print ln do, will it run do? Errors imported but not used. Oh, I could use this in the neural networks from scratch series. I have in some places the function that only like does something and returns error only, and I can shorten it because before I was like error, then shorthand assignment, and then if error is not equal to nil, so it's 2 lines, but I can shorten it into the 1 line. Okay. Errors declared inside if shorten also available inside any of the else blocks. That's cool. Both calls to the power returns the result before. Okay. So it means that the B is accessible here, right? Okay. Exercise, loops and functions. Okay, let's do the exercise and probably stop today. Yeah. As a way to play with the functions and loops, let's implement a square root function. Given a number x, we want to find a number z for which z squared is the most near one. Computers typically compute the square root of x using a loop, starting with some guess that we can adjust it based on how close so they producing a better guess. Repeating the adjustment makes the guess better and better until we reach the answer that is close to the actual square root. Implement this in the func square t provided decent starting guess for z is 1, no matter what the input. To begin with, repeat the calculation 10 times. Repeat the calculation 10 times and print each z on the way. See how close you get to the answer for the various values and how quickly the guess improves. Hit to declare and initialize a floating point value, given it float point syntax, use a convention. Okay. Next, change the loop condition to stop once the value has stopped changed or only changed by a very small amount. See if that's more or fewer than 10 iterations. Try other initial guesses for d, like x or x divided by 2. How close you are functions result to the math square in the standard library. Now, if you're interested in the details of the algorithm, that d square minus x above is how far away the square is from where it's needed to be x. Okay. And then division by 2z is the derivative of, to scale how much we adjust z by how quickly the square is changing. The general approach is called Newton's method. It works well for many functions, but especially well for the square root. Okay, where so there is this one. Okay, I probably will. I'm not sure how long it will take my time. And I wanted to have the first video around 30 minutes, so that's already on time. I will start the next series actually from building this exercise, and then we will go into, where is it? Switch statement, switching differs, taking differs, and congratulations, and then more types, structs, slices, and maps. And yeah, turns out I covered a lot, like in 20 minutes, something like this, which is good. Okay, thank you for watching and see you in the next video. Bye bye.